And welcome again. And there is one more problem we are going to solve. It's just switching the key or shifting it from one position to another. There is one more kind of problem, and you can see here. Focus on the statement of the problem that says capacitors connected according to the circuit shown in the figure. I can see there are four capacitors C1, C2, C3 and C4, and are connected at points A and B to a source of EMF E. So a battery is being connected like this, and then disconnected from it, okay, with switch K open. Well, after this key K is closed, what charge will flow through point A? Okay, before equilibrium is established, C1, C2, C3, C4 is equal to 3C, and the rest of them are C. This is the problem, you can see, and it is properly written. But the initial condition is that the EMF source is connected and switch K is open, and in such a case I can see that C1 and C3 are connected in series, and so C2 and C4 they are also connected in series. So C1 and C3 will have same charges. Let's call them Q1 and Q3. So Q1 and Q3 will be equal to will be same, and this can be written as E multiplied by capacitance, equivalent capacitance of C1 and C3. Since they are in series, so their equivalent capacitance I'm writing simply as 1 plus 3, and it's going to be E C1 C3 divided by C1 plus C3. So this is the charge on left of the capacitors. Now the charges on capacitors C2 and C4 are also same, so I am going to write Q2 equals Q4, and its value becomes the EMF of the voltage source multiplied by equivalent capacitance of 2 and 4, and that is going to be E C2 C4 divided by C2 plus C4. Yes, and right now when the switch K is still open, the potential difference between points M and N is equal to, since this plate is positive and this is negative, this is positive and this is negative, so potential difference between points M and N, I am starting UM, and then I am moving from lower to higher potential. That means I am gaining the potential, and the gain is simply Q1 by C1, and then reach at capacitance C2, and in crossing the capacitor C2, I'm going from higher potential to lower potential. That means I'm losing potential by an amount of Q2 by C2. So I would like minus Q2 by C2, and then I reach to point N, and this is the potential at N, and I can write the potential difference now. um minus u1. I can get the results. And um minus u1 I will get simply as something like E C3 by C1 plus C3 minus C4 by C2 plus C4, like this something. And now if I close the switch, close it, let's close it, the potential difference between points M and N will be reset to 0. That means M and N are now equipotential, and that means this circuit or this circuit below, but I'm focusing on one part of the circuit, will be discharged. And that means total charge Q equals C1 plus 2, equivalent of C1 and C2. And after connecting this, they are now in series. You can see them after connecting this switch. C1 and C2 are in series. So this much charge Q equals C1, equivalent of C1 and C2, multiplied by potential difference between M and N, will flow through the point A, and that's your answer. Thank you very much for watching.